All right, here's rule number 3. Rule number 3 is called the constant multiple rule. Okay, we're finding the derivative of a function that has a constant c in front of that function, or that c could be factored out from the function. Then how does that affect the derivative? Okay, let's take a look at an example. An example of that would be something like this. You have f of x is equal to 5 times the x to the third power, or you could think of that 5 as a constant value in front that is being multiplied to another function, x to the third power. Okay, in this case, that function would be u, and the c would be constant right there. So what would happen here? Okay, so the constant rule is this. Okay, if you're taking the derivative of a constant multiplied by a function, you could take that constant outside of the derivative and just simply find the derivative of the function u. Okay, I'll give you another notation for this, a little more formal notation from another textbook. D dx of c times df of x is equal to c times the derivative of f of x itself with respect to x. Okay, so here's a little more formality. If you want a little less formality, I guess you could do this. Okay, so c u, where the c is a constant value. Okay, this is informal. This is very informal. If you're finding the derivative of cu, where c is a constant value, then it's the same thing as finding the derivative of u. So u is a function. Just finding the derivative of u and then multiplying by the same constant c. And these two will have the same result. Okay, so I'll give you an example of this case. Then if the function of x is defined to be 5x to the third power, then f prime of x would be simply 5 times the derivative of the function x to the third power, which would be 3x squared. Then you proceed to simplify that, which would give you 15x squared. Okay, let's take a look at this one. Okay, this is not a proof, but okay, I'm gonna give you more examples here. If g of x happens to be negative x, then if g of x equals negative x, then g prime of x, or the derivative of g of x in general, would be negative 1 times the derivative of x, which would just be negative 1 times 1, which is equal to negative 1. Okay. Do you always have to separate them? You don't have to. Once you know this constant multiple rule, okay, you could just take care of it as it is. So if you look at this one again, go back to 5x to the third power. What you could do is you can know that the exponent 3 will be multiplied to 5, so you get 15, and then you downgrade the exponent by 1 to get 15x squared. So you don't need that. You don't necessarily need that intermediate step.